Oh, hello, this is Chris, and we are taking a look at questions 18 and 19 here in section 4 of SAT Practice Test 4. So let's dive right into number 18. Jim has identical drinking glasses, each in the shape of a right circular cylinder with internal diameter 3 inches. He pours milk from a gallon jug into each glass until it is full. If the height of milk in each glass is about 6 inches, so height of 6, diameter of 3. What's the largest number of full milk glasses that he can pour from 1 gallon of milk? And they give us a conversion factor here of 231 cubic inches in a gallon. Okay, so the shape we're dealing with, we have a cylinder, and it's going to be, each one of these glasses has a diameter of 3 and then a height of 6. So to figure out the volume of one glass, this is an equation we probably should know. However, they do give it to us at the beginning of the math section in our little cheat sheet. But the volume of a cylinder is going to be pi r squared h. And so here, let's figure out the volume of one of these glasses, and then that way we can divide it to see how many would fit. So here, this would be pi times, now your radius squared, just be careful here because they give you 3, but that's the diameter. And remember, your radius is half the diameter. So if the entire diameter is 3, your radius is 3 divided by 2, which is 1.5. So this would be 1.5 squared for the radius, and then times that height of 6. So your volume of one of these glasses, when you multiply that out, this will be, let's see, if you do times pi, it comes out to a little bit of a messy decimal. It's 42, about 42.4. 42.39 here. And then in order for us to figure out how many there are, well, if we're pouring a full gallon, which means 231 cubic inches, and we can use that value because everything here is measured in inches, so we know that our volume is in terms of inches cubed or cubic inches. So here we're going to divide 231 by 42.39, and when we do that, let's see what we get as our answer. So that's going to come out to be, let's see, 42.39. So that division will give us 5.45, about, roughly. So we know it's either going to be 5 or 6, right? But we have to figure out which way to round appropriately. And in this case, they want to know how many full glasses. So basically what happens is we're filling up 5 glasses, and then we're filling up a small portion of a 6th glass. But to figure out full glasses, you're really just looking at this number here. Even if it had come out to be 5.99, technically speaking, as close as that is to 6, we would still, for this particular word problem, round down. Its number of full glasses would be only 5. And that's sometimes difficult because a lot of times with rounding, we get so used to automatically rounding to the closest value. But in a lot of SAT word problems, you're going to have to either round up or round down depending on the wording of the question, regardless of the decimal. So one little thing to keep an eye out for there. That can hopefully be helpful to you in the future. All right, let's take a look at question 19. This one looks a little shorter, so that's nice. It says, if 3p minus 2 is greater than or equal to 1, what's the least possible value of 3p plus 2? All right, well, let's figure out a possible value for p. So this inequality that we start with, that's enough for us to do some solving. So here we add 2 to both sides. 3p would be greater than or equal to 3. Divide by 3. P is greater than or equal to 1. So they want to know the least possible value. And if we're looking for this to be the least possible value, then when we plug in for p, we want p to be the least possible value. And if p is greater than or equal to 1, then that means that 1, in this case, and I'll color code this a little bit, but this would be the least possible value for p in this case. And so we're going to have to use that least possible value. A lot of people do the first inequality correctly and they get a little stuck here. But least possible value means that you have to pick the smallest value for p in order for this expression to be its smallest or least possible value. And so here we would plug in a 1. 3 times 1 plus 2. 3 plus 2 is 5. That's our least possible value. And again, depending on what the question's asking for your inequalities, you want to make sure that you match the appropriate either greatest possible or least possible value.